The question is, consider the following augmented grammar with hash, less than, greater than, A, B, C as the set of terminals, right? And this is the augmented grammar in front of us. And let I0 equals to closer. Closer is simply means that we need to add a dot on the left hand side of all right hand side productions. Means on all this right hand side production, I need to add this dot. This is called as closer, right? I hope you all know about it. The number of items in the set go to, again then go to I naught less than. So I need to traverse this less than symbol twice, right? And in traversing this less than symbol twice, whatever number of states, whatever number of item I will get in that state would be the answer of this question. Okay, let's see the question. First, I am converting this augmented grammar into closures form. So I can write it, or I can simply rewrite it like s dash derives dot s derives dot s hash C and S derives dot double S, rule number 3, S derives dot S and at the rate, it is my production number 4, S derives dot angle brace or open less than S capital, okay, closer brace. S derives dot A, S derives dot B, and S derives dot C. Okay, so this is my I0 state. You can assume it as a I0 state. Okay, this is my I0 state. Now what I need to do now, I need to traverse on less than symbol. So first I am solving this part. Go to I0 less than. I am solving this part. So on less than symbol, I have this transition on less than symbol, if you will see. So this dot will move one position to the right hand side, right? It will move to the one position to the right hand side. So it would be like S derives less than dot S and then close. Okay, now if you will see here, this dot have non-terminal on its immediately right hand side, or you can simply say that this non-terminal is having this dot on its left hand side. So I need to include all the productions which is related to S. So I will write S derives dot S H C and S, that is I have write this one. I need to write all the production that is starting from S because it is the rule of this grammar. S dash dot double S, S derives dot S at the rate, S derives dot S and get greater than, S derives dot A, S derives dot B, S derives dot C. Okay, now this is the next step, right? Now if I need to again, now I have solved this part, right? I have solved this part I have solved. Now I need to solve this part, this go to part. For this I need to again traverse on this less than symbol. So if I will again traverse on this less than symbol, you can simply say that I will get the same state. No need to write it again, right? So on less than symbol, I will get this state again. So I have merged this state into the same state, right? So what I need to calculate now? I need to calculate number of items in this set. 1, 2, 3, 4, 5, 6, 7, and 8. So total number of items in this set is 8. So 8 is the correct answer for this, guys. I hope it is clear to everyone. Just use go to properties, just use closure function properties, and I hope you all know about what augmented grammar is, convert into closure set, and then just traverse on the input symbol which is given to us and just count the number of items. So it is clear to you. 8 is the correct answer for this GET question. Thank you. So the question here is, in the context of compilers, which of the following is not an intermediate representation of the source program? So option A is abstract syntax tree, option B is tree address code, option C is control flow graph, and option D is symbol table. However, this question is very simple. You can directly answer it, but I am evaluating this question and I am analyzing this question completely. So guys, basically for any high level language program, right, the phases basically are lexical analysis phase, and after that we have syntax analysis phase, after that we have semantic analysis phase, and then we have intermediate code generation phase, right? ICG, generally intermediate code generation phase. So for any high level language, lexical analysis phase जो है, it is generally it do have it basically checks for lexical errors and it generates tokens. Tokens are further passed to syntax analysis phase. They recognize syntax errors, generate syntax tree or parse tree, and pass this to semantic analysis phase. They are here semantic errors will be checked and generated semantic trees, and this will be passed to intermediate code generation, which would be of like 3 address code directed acyclic graph, right? It would be of type syntax trees or postfix notations, right? So these 4 types generally used. So 3 address code like T1 equals to A plus B, or like T2 equals to T1 into C, like that, right? So this is 3 address code which is generally used as an intermediate representation. If we talk about abstract syntax tree, then abstract syntax tree is like multiplying something result of suppose A plus B and multiplying the result of A plus B to suppose D. Such thing is abstract syntax tree, right? And then control flow graph do we have, in which some expressions are here, right? Then expressions are basically added, or they may be multiplied, or there may be condition check that if this then, right, if expression is there else, like that. So this is a control flow graph thing in the intermediate code generation. So ultimately only option D is remaining, symbol table, which generally it is generally a data structure, which is used to store the function names, variable names in the various compiler phases, like that, right? So it stores the data of all these compiler phases, right? So D is not an intermediate representation of the source program. It is a data structure to store various information of all the phases of compiler design. Whereas option A, C, and B are practical intermediate representation of any high level language code, right? So option D is correct for this GET question. I hope it is clear to you. Thank you. So the question here is, for a statement S in a program, in the context of liveliness analysis, the following sets are defined. 3 sets are defined here: use, in, and out. Use set say that the set of variables which is used in S. In S means the set of variables that are live at the entry of S, and out S means the set of variables that are live at the exit of S. Consider a basic block that consists of 2 statements, S1 and S2. Which one of the following statement is correct? Which of the following statement is correct? Out of S1 equals to in of S1 union use of S1. Option B, out of S1 equals to in of S2. Option C, out of S1 equals to use of S1 union in of S2. Or option D, out of S1 equals to in of S2 union out of S2, right? So to solve this question, we can easily solve this question using the given information. Suppose we have S1 block which is immediately followed by S2. Okay, so suppose we have S1 block which is immediately followed by S2. Now you can observe one thing here, that whatever at the out of S1, whatever variables which are live at the out of S1, right, would be live at the in of S2, right? Using property of liveliness, we can simply say that suppose P and Q are two variables which are live when they exit from S1, means from out of S1, suppose P and Q are live, then this P and Q while taking entry into immediate block, that is S2, they will be live at the in of S2 as well, right? So option B, that is out of S1 equals to in of S2, it is the correct answer for this GATE question. Okay guys, so I hope it is clear to you. Thank you. The question is, consider the following ANSI C program: int main, integer x, return 0, and the question is, which one of the following phases in a 7-phase C compiler will throw an error? Option A, syntax analyzer; option B, lexical analyzer; option C, semantic analyzer; or option D, machine dependent optimizer. So guys, if you will observe this program, then we need to know about the 7 phases of compiler design, right? At initial, we have a piece of code, and this piece of code is nothing but characters of string like this, right? These are the characters of strings, or piece of code is there, or you can simply say that high level languages are there. It will pass through first phase. First phase is nothing but lexical analysis phase. Now, if I will pass this code to the lexical analysis phase, what would be the output? Output would be tokens or sequence of tokens. Now, if I will pass this code, then it will be converted into tokens. First token would be int, next token would be main, next token would be open brace, next token would be close brace, next token would be open curly brace. So total I will get 1, 2, 3, 4, 5 tokens from line number 1. This is line number 1. From line number 2, I will get 1 token, 2 token and 3 token. From line number 3, I will get 1 token, 2 token and 3 token. And from line number 4, I will get 1 token. So total, if you will observe, 5 plus 3 plus 3 plus 1, that is 5 plus 3, 8 plus 3, 11 plus 1, 12. I will get 12 tokens, right? So lexical analyzer phase will not show any error because I am getting 12 tokens successfully, right? That is why I will not get any error. Now these tokens will be passed to second phase, that is syntax analyzer phase. And syntax analyzer phase will check syntax. Now, if this code will be passed through the second phase, int main, open brace, close brace, curly brace, line number 1 will be passed successfully. And when line number 2 will be compiled, integer is there, right? Integer. This word will be there, that integer. But in the standard ANSI C library, we don't have any keyword like integer, right? That is why it should have to show error. That syntax error is there. That is why I will say that option A is the correct answer. However, if you will run this code on any compiler, any online compiler or any GCD compiler, you will get an error like integer or unknown type keyword integer found. It itself means that syntax error is there and it will be analyzed by syntax analyzer. So syntax analyzer phase will throw an error. That is why option A is 100% correct answer here. Thank you guys. Consider the following ANSI C program: Z equals to x plus 3 plus y derives f1 plus y derives f2 For I equals to 0, I is less than 200, I equals to I plus 2. If Z is greater than 1, then P equals to P plus X plus 3 and Q equals to Q plus Y plus F1. Okay. And else we have P equals to P plus Y derives F2, Q equals to Q plus X plus 3. Question is, assume that the variable Y points to a struct allocated on the heap containing two fields F1 and F2, and local variables X, Y, Z, P, Q, and I are allotted registers. Common sub-expression elimination optimization is applied on the code. The number of additions and dereference operations of the form Y derives F1 or Y derives F2 in the optimized code respectively are. So this is the code which is given to us, and common sub-expression elimination is applied, and we need to answer number of additions and number of dereference operations here, right? So guys, do focus here, do focus on the question. I am solving this question step by step, and you may get some kind of confusion while solving the question. So stay patient, do watch the video till end, and watch complete solution step by step, right? So let's start. Here we have Z equals to X plus 3, right? So what I will do, I can write T1 equals to X plus 3, right? I write it in the form of 3 address code. T2, I can further T2, I can write it like Y derives F1. So for Y derives F1, how I can write it? I can write it like T2 equals to Y derives F1, and Y derives F2. I can write it like T3. T3 equals to Y derives F2. Okay. Now if you observe, I can write this Z. I can write this Z equals to T1 plus T2 plus T3. Okay. I can write this because T1 is X plus 3 plus Y derives F1, that is T2, and Y derives F2, that is T3, right? I can write this like that. Now after that, for loop is starting. This for loop is I equals to 0, I is less than 200, and I equals to I plus 2. If Z is greater than 1, P equals to P plus X plus 3, right? So I can reduce this code, that is I can optimize this code X plus 3. For X plus 3, I can write T1. So I can write it like P equals to P plus T1. And here Q, I can again optimize it like Q equals to Q plus Y derives F1. It simply means that Q equals to Q plus T2. I optimized it using these rules. Else, I can write it like P equals to P plus Y derives F2. I can write it like P plus Y derives F2, that is T3. Right. And Q, I can write it like Q plus Y X plus 3. X plus 3 is T1. Q plus T1. Okay. So guys, if you will observe here, T equals to X plus 3. What I am doing? One addition is there. Right? Y derives F1. What is here? One dereference. T3 equals to Y derives F2. What is here? One dereference. And Z equals to T1 plus T2 plus T3. So here two additions are there. Here two additions are here, right? Now if you will see here, P equals to P plus T1, here one addition, and here Q equals to Q plus T2, one more addition. Okay. Else, in else part, P equals to P plus 3, that is one addition, and Q equals to Q plus T1, that is one addition. So basically in if part I have two additions, and in else part I have two additions. Okay. Now focus here that in this for loop, that is I less than 200 and I equals to I plus 2. This for loop this for loop, this for loop will run how many times? This for loop will run 100 times, isn't it? This for loop will run 100 times. And so this increment operator is having addition I equals to I plus 2. That is why this increment operator will be run 100 times. So 100 additions would be there. 100 additions would be there. So I have write 100 additions. Now as this loop will run 100 times, so either if will execute it or either else will execute it. Whatever is executed, each is having two additions. Each is having two additions for 100 times. So 100 multiply with 2, that is 200 additions I will have here. Why? Because this loop is running 100 times, and each block, either if or else, each is having two additions. That is why 100 into 2, 200 additions I would have to do. So in code optimization method, 200 plus 100, 200 plus 100, in the loop this much additions will be performed, and no dereference is here. And before this loop I have two additions here and one addition here. So 200 plus 100 plus 2 plus 1, that is 303 additions I have to do. 200 plus 100, this 200 is for loop additions, this 100 is increment additions, plus 2 additions this one, and plus 1 addition this one, right? So total I have 303 additions, isn't it? Now if we talk about dereference, then in this loop, in this complete loop, we don't have any dereference. Only before loop we have these two dereference. So total dereference is 2. Okay, total dereferences are 2. So if you'll observe the option C, that is 203 additions and dereferences are 2, right? So option C is the correct answer for this question, guys. I hope it is clear to you. Just focus the video, and one by one we have solved this, right? So I think nothing is like of confusion in this question anymore. Have a very nice day, guys. Jai Hind, Jai Bharat.